We are going to continue with exercises 3, 4, and 5 for lesson 8 about estimating quantities. In exercise 3, it says that the estimate of the number of the stars in the universe is 6 times 10 to the 22, and the average human can see about 3,000 stars with the naked eye. How many times more stars are there in the universe compared to what a human can see? So again, I am dividing, and I am going to take the total number of stars in the universe, 6 times 10 to the 22, and I am going to divide by what a human can see. So I'm going to rewrite 3,000 as 3 times, there are 3 zeros, so 3 times 10 to the 3. Again, I'm going to do a 2-part division problem. First, I'm going to divide this 6 divided by 3, which equals 2, times 10 to the 22 divided by 10 to the 3 gives me 10. 22 minus 3 is 19. So there are approximately 2 times 10 to the 19 more stars in the universe than what a human can see. Exercise 4. The estimated world population was 7 times 10 to the 9, and of that total population, 682 million were left-handed. What percentage of the world population is left-handed according to this estimation? So in this case, if I'm trying to find the percentage of left-handed out of the total, I'm going to take this number divided by that number. Now, this lesson is about estimating. So the first thing that I'm going to do is I'm going to estimate this number as approximately 700 million. So 700 million would be, there are my thousands and there are my ones, tens, hundreds. So it would be like this. So I am going to rewrite this number in the form of a single digit times the power of 10. 7 times 10 to the 8th divided by the total number, 7 times 10 to the 9th. 7 divided by 7 gives me 1. And then 8 minus 9, that's going to give me a fraction here. So I have more left over. I'm going to do the 9 minus 8. The one that's going to be left over is in the denominator. So 1 over 10 to the 1, or 1 over 10. And 1 times any number. So again, this just equals 1/10. 1/10 as a percentage is 10%. So the percentage of the world population that is left-handed is about 10%, according to this problem. Exercise 5. The average person takes about 30,000 breaths per day. Express this number as a single-digit integer times 10. 3 times 10, and I have 4 zeros, so 3 times 10 to the 4th. Now, if the average American lives about 80 years or 30,000 days, about how many total breaths will a person take in her lifetime? So in this case, how many total breaths? I'm going to multiply the number of breaths per day from the first part times the number of days in a lifetime. So I'm going to rewrite this. This 30,000 is 3 times 10 to the 4th, which means this 30,000 is also 3 times 10 to the 4th. So 3 times 10 to the 4th. And then I'm going to multiply them together. And again, I can do the same thing. I can do a 2-part multiplication problem. 3 times 3 is 9 times 10. When we have the same bases, we add the exponents. So 4 plus 4 is 10 to the 8th. I can write it as 9 times 10 to the 8th, or I can write it out in standard notation. Then I'm going to check where my commas go here. Okay, so I have 900 million breaths in a lifetime.